Let's have a look now at the learning analytics architecture and how the learning analytics processor coupled with the learning records warehouse can really make things happen.
So in the warehouse we need to store two sets of data about the students and the things they do. When it comes to the student, there was no existing standard to define this data at all. So we had to develop our own standard in this space based on existing work, particularly around HESA's work and the independent learning record, extended to hold the kind of items that we need for learning analytics analysis of the data. So we work with all the people involved in the project, develop an open specification for the student. We call this the universal data definition, and make that available. We then have to describe the things the student does. In the project, we're using a standard called XAPI. There are two standards in this space, XAPI and Caliper, and we expect them to gradually converge over the next few years. They essentially work on the same process. There's a person who does something, and this is what the outcome is. So what we want to achieve is that the same activity is described in exactly the same way, regardless of the technology that's used. So as an example, you may have Blackboard and Moodle as different virtual learning environments. We want a student logged in and looked at a course item to be described in exactly the same way in both systems. So this is where XAPI fits in. We then work on plugins to those systems that emit data in exactly the same format, regardless of the system you used. So what you can do with XAPI is extend it beyond things like VLEs to describe things like entering into physical spaces, borrowing books, all sorts of things. So what we're doing is collecting a whole group of recipes to describe these activities, sharing them so that everyone describes them the same way. This means that then we can have tools that work at an institutional level across the data and behave the same way from one institution to the next, but we can also then allow people to share tools, visualizations and so on, and look at aggregate data across the warehouse. For learning analytics, there are different data sets that can be used to predict or help predict whether a student's going to succeed. So typically these are things about the students, but more importantly the things they do. The first data set, and probably the strongest predictor, is actually their marks for individual assignments. This might seem like an obvious piece of information, but what we find is typically that it's actually module marks that are held centrally, and it can be quite a challenge for institutions to collate assignment level information. Still, that's really important. We've defined a standard now for collecting this, and really there's no one-size-fits-all approach to getting that data. It's something that institutions need to work on. And I think it would be my first piece of advice if you're starting down this line, start thinking about that set of data. The next set of data is really things that are proxy for engagement. So these are things like use of the VLE, the library, various systems. The way we're tackling this is to look at the most commonly used systems first and build plugins for those that can work across the sector. So the first thing that we've tackled is virtual learning environments. So in the UK, Moodle and Blackboard have got about 90% of the market share between them. We've developed a plugin for both of those, so it's a very simple case of installing it. It takes about a minute, and you can start then collecting your VLE data in the standard format. We're moving on then to library systems, which is actually far more complicated. It's complicated because there are no dominant vendors in this space, and the systems there typically don't have easy ways of getting the data. So if we think about the kind of data in the library space, we've got physical library use, so we've got borrowing books, we've got physical attendance, we've got coming into the library, and then we've got use of electronic resources. The feedback we had from the library community was that the latter was the most important. So what we're doing is, again, getting proxy data on engagement with library resources. So typically things like logging into systems where you would get access to this kind of information, things like access to reading lists and systems like that. The next big area of activity is around attendance. So it's worth thinking of attendance as two separate concepts, presence and attendance, and we're tackling them both separately. Presence is when you come into a space, typically in an unscheduled way. So you come into a library, a sports centre, perhaps you just come to the university, and this is typically gathered by things like proximity sensors, card readers, that sort of thing. And then you've got attendance, so this is when you go to somewhere you should have been. So this typically will be a lecture, a tutorial, that sort of thing, a scheduled event. It's more complicated because you have to correlate things like timetable data with physical attendance data. So what we've done, we've defined a standard, again in XAPI in this space. We're working with a number of institutions that actually have the data in some reasonable format, putting it into this standard format and seeing where that takes us, but it's a complicated space.
The Learning Records Warehouse is vital in terms of both the historical data processing and the creation of these learning analytics processes per institution in the first place. So the historical data between 1 and 3 academic years worth of student progression data per course, module and assignment, coupled with their digital footprint and activity data, really has to be stored in terms of its size and its complexity in a robust, secure and industry standard database system, and that is the Learning Records Warehouse. So the Learning Records Warehouse is to cater for several different universities, updating several 100,000 and million data items all at the same time. And bringing this together requires capacity, but also computing power, and that's what the Learning Records Warehouse is. It's a data powerhouse for learning analytics. When we talk about a multi-tenanted data warehouse, which is effectively what the Learning Records Warehouse is, what it does, it means that each institution has their own secure and isolated data storage environment, and also in terms of computing power as well. We can actually dedicate space and processing power to manipulate that data for learning analytics on a per institution basis. The data is completely segregated. It may live on the same physical hardware over in the cloud within Europe, but at the end of the day, each institution's data is securely segregated and used specifically and only for that institution's purpose with learning analytics.
Okay, so the learning analytics processor is really a concept rather than a physical item. So it's one of the elements in our architecture. Different suppliers supply different processors. Conceptually, though, they all work in a similar way. So what they do is there'll be a piece of software that pulls in live data in the first instance and predicts, based on that data, whether a student is going to achieve whatever you wanted them to do, whether they are going to pass, get an upper degree and so on. They do this by running a model which is based on historic data. So what we have to do at the start of the project, when we work with any institution, is get typically between 1 year and 3 years of historic activity data. This allows us to then create a model to predict something, run it against test data to see if it actually works, and end up with a model that will hopefully give a reasonable degree of accuracy predictions when you run it against live data. There's no single technique that the LAP uses for machine learning. It varies from product to product. Typically, though, these will have names like regression analysis, classifiers, ensemble learning, all sorts of kind of well-established techniques for getting predictions. They will typically be developed by a team of data scientists in the vendor or suppliers analytics team. They'll come up with a model that's fairly bespoke to your institution, and the openness of the model varies from system to system. So our open source solution, any data scientist, for example, can interrogate the model, try and understand how it works. Some of the more commercial solutions, that's not possible.